this is our carport. So this system we have made to control these parking lights whenever we want to on and off. But now we are manually switching on and off these lights. With this equipment, we can directly control these lights automatically. We no need to spend our time on this. So this is the switchboard. So now we have to mount this automation unit here, and the wires from this will directly go to the switchboard, and these lights are controlled by this control unit.
So now you can see the brain of this particular automating unit, that is the microcontroller board. The microcontroller I have used is Atmega 328P, which is same as the microcontroller used in the Arduino Uno. And I have given a 12 megahertz external clock, you can see. And the timekeeping IC, that is the real-time clock I have used, is DS1307, the most widely used and simple and cheap RTC available in the market. And this is communicating with the microcontroller via I2C communication that everybody knows. And there is a CMOS battery, you can see, that is CR2032 battery I have used for the backup for the RTC clock. And RTC is having a 38 kilohertz crystal oscillator, that also you can see. On the top you can see some 16 jumper header. They are for the 16:2 LCD display connections, but I have used only the 4-bit communication with the 16:2 LCD. And below that you can see some 6 jumper header. They are for the programming the microcontroller. They are ICSP link to the microcontroller. So that is having a VCC, ground, reset, MOSI, MISO, SEK. And bottom you can see some 5 to 6 lines. They are actually driving the relay board that I will show you next to this particular slide. And there are 2 buttons available, press buttons. One is for reset and the other is the menu button that I will be demonstrating after installing this unit, how what is the purpose of that particular menu button and how we can change the time and the alarm limits and all. That is the microcontroller board. Now we will see the relay board, which is having 4 relays mounted on a single board. This I have directly procured, and that in online market you can procure such kind of relay boards. And this is a opto isolated input relay board. So there are 4 numbers of opto isolators are there, and the lines I have taken VCC, ground, and the input to the relays. And this particular relay board will be connected to the microcontroller board. Jumper header I have explained just now. And the units or the lights to be controlled is connected to the relay output. The line we are connected to the poles of the relay, and the different equipments or the lights we have connected to the normally open relay contact. So whenever the microcontroller give the signal to energize the relay, a particular pole and a normally open contact will get close. Accordingly the lamps or the equipment will get turned on.
And this is the LCD, you can see. And the boards I have assembled inside this plastic box, as you can see here, with the help of a standoff. And the input and output to the relays can be taken from these holes provided. So I have indicated the pole, NO and NC contact here on the relays. And this is the power supply line, that is the phase and neutral line for the system. Now we will see the inside. So this is the microcontroller board and this is the relay board, and I have connected the microcontroller board and the relay as you can see here, and this is the line for the power supply and this is the line for the fault LED, and this is the CMOS battery for the battery backup for the RTC, and this bunch of lines are for the 16:2 LCD display. Okay, so now we'll see its performance after mounting it on the wall. Now the units we have installed here like this, and the two lines for the power supply and the other two lines for controlling, means other two are relay lines, and that has been given to the switchboard. So whenever the condition has been triggered, the particular lamps will get turned on. So this is the physical appearance you can see. So it will show the timing, month, day, date and the year, and there is a fault LED as I told, so that will indicate, that will turn on whenever there is a fault happened inside the system. So now we will see inside how to set the alarm and how we can change the time and all. So this design is such a way that we no need to reprogram anything. So if you want to if you want to change the alarm setting, or something happened to the CMOS battery and the time is showing something different, so there is a provision I have given. With that provision we can change the alarm limit as well as the time without reprogramming the system. So let me show you how we can change the setting of this unit. So like this we can open it, and I have provided two switches inside. One is for the reset of the system and other is for the menu. So once I have hold the menu button, it will enter into the setting mode, and so this is the CMOS battery you can see here, and this is the RTC, and this is the microcontroller Atmega 328P, and you can see these four relays will be controlling the lights, and there is a 4 LED also on board. This will indicate whether the microcontroller has been turned on any lights or not. So there are four channels available you can see. So from this you can see that the third channel is not on, so maybe that it is the time has not been reached to switch on that particular lamp. And I have provided two switches inside. One is for the reset of the system and other is for the menu. So once I have hold the menu button, it will enter into the setting mode, and like we can change the time. So now we can change the hour and similarly minute. If you want to change the minute, if you hold, different modes will come, and a single press will increase the particular value. Okay, so I'm not going to change right now since it is already the time has been set. So the seconds change mode, year change mode, month, date. Now here is the alarm. This is the mode where we can set the alarm limit. So the light 1 start time will indicate the time to be set to turn on the first relay or the first light, whatever it may be. So here we can set the start hour, means when the light should turn on in hour, and its particular minute. Okay, so both the input we have to enter. Similarly, the next one is to stop the light. So this will indicate the which hour or what time the relay as well as the light to be turned on, and it's also having the minute. So you can set the starting hour minute as well as the stopping hour minute. So this provision I have given for all the 4 relays, so through which we can independently control these relays at our own timings. So different timing is possible with this. Without a reprogram we can adjust this timing, and this will turn on and off as per our setting. So this for 4 lights we can change, the setting can be changed as you can see here. Some of the special features I have incorporated in this particular design is that these 4 relays we can independently control, means different timings can be set, that I have already explained. and there is a switch provided here. This switch is provided in order to have a manual as well as an auto control. See, the major is that this is a fail-safe kind of a design. That is, if assume this system is failed, then we should be able to control these lights from the switchboard. This should not cause any problem to the existing system. That is the main design criterion what we have discussed. So that with this switch, if you put in manual mode, we can independently with this switchboard we can control, and if you put in auto mode, this particular system will start controlling the lighting. 6 o'clock actually it should get on based on our setting. So these alarm conditions actually I have stored in the EEPROM, so that power failure does not cause any problem. So the alarm conditions or the alarm limits will be stored in the EEPROM. Okay, so actually now the lights, you can see the relays are get turned on, and the force lamps also turned on right now, you can see here. So this is how the system works.